where do we see this going in the next 1 to 2 and 2 to 5 years, right? I think we're going to see a growing use of synthetic data in the finance and healthcare world as they deploy models in an environment to get them to a place where they can be employed on real data, which I think is a good use of this synthetic data. We're also going to see it and have seen it in AI generated videos, deepfakes, right? They're becoming very advanced and very hard to tell the difference between what is real and what is fake. There was actually a 6 hour auction in China on a social media with two AI generated individuals based on real individuals, but they sold $7.5 million in merchandise over these 6 hours. And that was entirely AI generated. What's up, Jay?
Hey Nate, how you doing?
I'm good. I'm excited for this podcast.
Yeah, this one's going to be mind blowing. I mean, as we just continue to progress through these topics, ready to roll.
This one we're gonna jump into it, right? We're gonna talk about synthetic everything. It was a chapter we featured in the Pluot report. Synthetic biology, synthetic data, synthetic humans. It's huge.
I'm going to start with a quote here that I think just really defines how broad this is with the notion of synthetic everything in the world.
What is real? How do you define real? If you're talking about what you can feel, what you can smell, what you can taste and see, then real is simply electrical signals interpreted by your brain.
Great movie.
Yes, it is. But in that theme that seems to hold, or that red thread across all of our podcasts, yet again, science fiction is becoming science reality.
Yeah, it's the hook. Like, what if everything we thought was real wasn't, right? Data, humans, biology. There's pros and cons to this, and one of the things I want to jump in and kick off is synthetic biology, right? And let's talk about bodyoids. We featured this in our report. A bodyoid is a brainless humanoid body that has all the organs inside of it. And, there's work that's being done to potentially get to this point for organ harvesting. And there's a lot of incredible things that can come from this. We talked last week about living intelligence and neurons on chips and organs on chips that, Nitri and Cortical are doing to mass produce organs on chips for pharma testing, for drug development. And this is kind of the future next step to this. And you're talking potential personalized medicine, no longer having to wait for organ transplant, right? And that's pretty awesome.
It really is. Although it certainly opens some ethical issues as well, because, looking at, we referenced the Matrix a few moments ago, and this notion of what is real and what's simply data or synthetic in the world around us. What about sentience?
Yeah, I love this question. This is a huge dilemma. We talked a little bit about it last week, but at some point you're going to have these bodyoids that have organs that we can use to transplant, that we can use to develop drugs, that we can potentially match the DNA biomarkers of an individual to get personalized medicine. But also with Cortical Labs doing the neuron-powered computers, we're not far off from having the ability to have a sentient bodyoid potentially. And there's a lot of ethical conversations that are going to come from that in terms of, does this sentient being have individual rights? Which I'm interested to see what the regulation comes from this and if it keeps pace with the technological advantages and technological advancements that are in this area. We're obviously not doing this tomorrow, right? This technology is really conceptual at this point, and it's being explored. But I don't think we're that far off in terms of, 10, 15 years from now, maybe. And these questions are things that we should consider before we do reach that threshold, right? We want to understand how we're going to go into this before someone makes that leap, and then we have to figure this out after the fact.
Right. I think you hit the nail on the head, though. The operative term is we should make these decisions or should have this ethical discussion, but are we?
No, I mean, you and I are. I don't know if it's writ large. Science is advancing at an incredible pace, and we're not keeping with that pace in terms of the discussion of regulation and governance and ethical use of AI or technology, especially as it pertains to what we put inside of us. You look at Neuralink, right? It's been implanted in the first human trials with some incredible success for paraplegic and those that are not able to use the full faculties of their body. I have not seen any regulation or ethical guidelines that go along with that technological development. We're just kind of sprinting full speed ahead into what this offers us. And again, there's some incredible breakthroughs that are going to come from this, right? Giving the ability for someone who is paraplegic to communicate, interact with the outside world in a more natural way is awesome. Potentially having the ability to eradicate the wait list for organ transplants is awesome. Being able to do personalized medicine that gets rid of, disease or allows us to have more precise vaccines and medicine is incredible. But there's some questions that we need to address head on before we run into this. Are we going to have a disparity of who has access to this care, right? We already have a potential wealth gap in this world in terms of the 1%, in terms of money. Access to care is largely dependent upon that. Do we get into a situation where the incredibly wealthy have the ability to just change an organ out as if they change their tires on their car, and those that are less fortunate have to just deal? These are questions that I'm interested in seeing how we answer them.
Yeah, no kidding. And so I think we're going to see this continuing saga of can we do it or should we do it emerging. And not only are we going to see that synthetic biology manifesting in terms of things like the humanoids and our ability to harvest organs, fresh, potentially optimized or nearly perfect organs for replacement. Will we see people replacing organs for an upgrade? Hey, I just want I want a better heart, or I want better lungs, versus I need a new heart because my heart's about to fail. And then how does that taper to that 1% line you talked about? Interestingly, though, too, is as we start to optimize this element that we've already described, we start to generate these options that are going to increase the lifespan of human beings. We're going to need a lot more than just organs to replace organs that are failing or wearing out. We're going to see a lot of impact as well on things like how is our agriculture going to be affected and our ability to generate the food stores we're going to need as we look at people living longer, living more active lives, and potentially being healthier as well.
Yeah, there's a lot of companies that are operating in this space on both the human biology side and the food agricultural side. And that question on extending the lifespan or the health span, we're going to get into that in a future podcast because we wrote about it in the Pluot report. Sticking real quick before we jump into the agriculture, I want to talk about two companies that are doing some awesome stuff on a micro scale within synthetic data and synthetic, drug development. Ginkgo Bioworks, they are doing cell programming for food, for pharma, and for chemicals, right? So they're using the ability to rewrite genes, DNA, to potentially look at safe alternatives for food manufacturing, right? That's the agricultural thing you just talked about. And the impact of that is eradicating hunger, ensuring that we are no longer having to overfish our oceans or hunt to the point of extinction of species that we can feed ourselves, right? A tagline that they have in terms of their company is they said they're able to read and write to DNA to program cells like we program computers. And I rock back when I read that because that's like, oh, that's awesome, but it's also scary as hell. They're essentially saying that they have the ability to reprogram the cells that are inside of us in order to get an outcome that they want, right? You can go down the path of, designer babies. You can also go down the path of, hey, I want a salmon, because I love salmon, I love fish, that is bioengineered, that has the same exact makeup as if I were to catch it wild on the Pacific Ocean. Another company, CRISPR Therapeutics, right? They do gene editing for sickle cell, or they do gene editing for therapies, and they have an approved medicine that treats sickle cell. And so you can take this right now in the US and Canada and Great Britain. And what CRISPR Technologies does is it goes into your cells and it takes out the damaged portion of a DNA strand, and then it puts in the portion of rewrites the DNA in order to come to a therapeutic solution, right? And so the idea is that you take this medicine, it rewrites and reprograms your cells so that you no longer have sickle cell. It's the difference between treating an ailment and eradicating it at the genetic level, which is pretty awesome. And we can do that with food, and they're doing that with chemicals in terms of safe chemicals, right? You think of, permachemicals that we have due to years of, trying to get rid of pests or fighting fires before we understood how they impacted the water source. There's a potential that we could create something that no longer has those negative effects, but has the impact that we desire.
This is really quite interesting, Nate. So really, we've got a macro situation where we could potentially grow replacement bodies almost for people. Maybe not even far-fetched that rather than taking all the organs out of the humanoid or the bodyoid, maybe you're just swapping brains at some point in time in the future, and just rewiring a brain into a new body and just having longevity that way. As we determine what the synthetic human looks like and the human components of the body, that's paired with this micro scale engineering, which is highly precise, which could be down to an individual's DNA and their genetics and repairing shortfalls. I won't say defects, but repairing shortfalls in that person's DNA to correct genetic disorders that they may have. And then I'm assuming everything in between is really in the art of possible and emerging right now.
It is, and that's where we need that guideline, right? We need those regulations, because if I can do a gene editing that gets rid of sickle cell inside my body, well, I can also do it to make my skin have greater complexion, or to maybe not lose my hair, which has some benefits to it, right? There is medicine that addresses that, but where is that line, right? Or am I doing it in terms of, I want my child to be 6'8" and be able to run a 4.40, or I want to have, the chemical makeup and the genetic makeup of a genius. And so I think we need to make sure that we're understanding where the left and right limits are of this, because we're not at the point of bodyoids. We're not at the point of sentient beings, but the building blocks are being explored rapidly that lead us in that direction.
And what concerns me is, and this has been a theme in other topics we've discussed, is the lack of regulation and governance covering this, because what you just described, everything from hair density to height to physical attributes, it could certainly be cognitive as well. Somebody somewhere will be thinking that they're optimizing an element of the human experience.
Yeah.
And the question is, are we going to fundamentally change it in our effort to optimize it?
Yeah, there's a big question of what it means to be human when we start entering all this synthetic data into the body, right?
Oh, yeah. Seems like we might be visiting the Blade Runner era, and where their advertising slogan was more human than human.
Yeah, replicants, right? Great movie. Both of them are awesome. So where does this lead us in the next 1 to 2 and the next 2 to 10 years, right? Next 1 to 2 years, breakthroughs in genetics, breakthroughs in gene therapies, early stage specialized bioengineered materials, potentially designer babies. Beyond that, 2 to 5, 2 to 7, 2 to 10, potentially sustainable food alternatives, right? And better medical diagnostics, which is incredibly powerful in both of those regards. And, there's the option or potential for personalized medicine. And I'm interested to see if this creates a health 1% for increased lifespan for those that have the means to provide for it. And as we wrap that section up, I want to pivot. We talked about the synthetic biology. Let's talk about the synthetic data, right? The use of these AI models is proliferating, right? We're using them for everything. And a lot of these large language models have reached the end of available organic data. And now we're exploring ways to synthesize that data so we can continue to train these models. There's a study by Gartner released recently that said by 2026, 60% of all data used for AI will be synthetic. That's pretty powerful, right? And so we need to unpack kind of what that means.
That is a really powerful prediction by Gartner. I'm going to say I hope it does not come true. And I'll say that because in essence, and we've learned this with some of the experiments you and I have done, when we use AI to try and synthesize something that AI has already summarized, it's an almost exponential loss of fidelity. If we take an original source paper, an AI summary, and then try and aggregate AI summaries, the loss ratio is certainly greater than just 2 stages of AI analysis. It's diluted way too much. And that's using real data, at least. That's saying, hey, look at these 10 source papers or these 10 books, and then funnel that in through some AI tools that look at the language in there. Imagine a world where it doesn't even have to use real data to start with. There's been a lot of really interesting dialogue lately, and I'll save the depth of this for our subsequent discussion. But the general shortfalls in AI, pointed out by Apple in their recent reports, pointed out by authors like Gary Marcus, in terms of there's some belief that AI may be hitting its point of diminishing returns in terms of its ability, specifically with large language models. So I have to be precise. I'm talking large language models with this part. LLMs may be reaching the limits in terms of what they can do to generate anything more accurate than they already are. And so what happens, and I'd love to hear your thoughts on this, if we're already seeing hallucination and we're seeing all sorts of odd outputs as a result of LLMs, if we now start to feed it synthetic data generated by other AI or generated by humans, and then what does that do? Is it a virtuous or a vicious cycle?
I think it's important to understand the bias, right? Artificial intelligence needs three things in order to be accurate or to be useful, right? It needs data. It needs to have compute, and it needs to have the right question asked, right? So if you don't have enough compute, you can't run the algorithms to generate the AI. If you don't have good data, you're going to get a bad answer. And if you don't ask the right question, you're going to get a bad answer. And so assuming that we have good compute and we are asking perfect questions, it goes back to the data that you said. And so it's always important to understand the bias that is inherent either in the questions you're asking or in that data. And as AI generates data, it's going to have its own biases based on how it was set up. And I think that's where the risk is, especially in terms of human thought or in large language models. But there is some benefits to using synthetic data, right? Two of them I'll give to you right now. One of them is in healthcare and finance, and the other is in designing test worlds. So healthcare and finance, right? Personally identified information is something that we safeguard for HIPAA reasons. I don't want everyone to know the status of my bank account or my credit score, but we need to have these models that can operate on this data. And so if you have synthetic data that you can train a model on, then the risk if that were to get out as it's learning doesn't expose people to the potential downside if there was an error or if there was, a breach. I think that's important, but that's a very specific use case, right? The other specific use case is in autonomous anything. Let's stick with autonomous driving vehicles, right? Because I know we saw the Waymo when we were down at South by Southwest in Austin. I want that thing to learn in a very safe, closed environment. I don't necessarily want it to test when it's driving around the Austin streets, right? I don't be like, hey, let's figure this out. Let's see how this goes. And then you have a pedestrian, get hurt or you have an accident. And so if you can design a synthetic environment where that program can learn what is a human, what is not, what's a stop sign, what's a traffic jam, how to avoid a distracted driver, I think that's another specific use case where synthetic data in terms of a synthetic environment is incredibly powerful. I think to your point, though, if we're using synthetic data as a means to drive original thought or feedback in terms of an AI tool, we potentially get into trouble. And, this is some of the things that I want to talk about in our next episode, right? Is that synthetic thought, that synthetic knowledge. And, there's that Rubicon in terms of what it means to be human on a biological scale. We're going to hit on what it means to be human in terms of the thinking scale.
So the way I think about what you just described with the synthetic data is, just as my interpretation is, there's a set of typical cases. We'll say, the average person, average physiological characteristics, or the average driving scenario for that autonomous vehicle. And we can use synthetic data so that we can quickly overcome either the learning curve in the autonomous vehicle's perspective, and maybe it's coming in with an 80% solution versus going out on the streets with a 30 or 40% training set in terms of typical scenarios. So we can operate in most scenarios and then quickly learn the margins. Or in the case of the medical aspect, perhaps it's hey, the typical scenario looks like this, and then it can start to search for those corner cases and build those with real data as well. That's how I'm interpreting what you're saying. Is that really how you conceptualize it?
Yeah, I think it's important to understand if we're going to use synthetic data, there's places where it makes sense as long as it's targeted and it's specific. If we use synthetic data for everything, I don't think that's a good thing. And there's some definite drawbacks to that, as you very succinctly generalized. And I think we got to just be careful as we go forward, as we sprint towards this growth of AI in our lives. We have to start asking some harder questions and not just take it for granted what it provides for us. So I think going into those challenges and risks, right? Does the synthetic data truly reflect the real world? I think that's a question you asked, right? Is it a hallucination? Is it, some echo or some, remainder of the original thought process that's giving me back this totally bizarre and bogus idea that I'm just going to take at face value? Or is it a true representation of a physical world that I can train a useful model on and then employ in the real world, right? I think it's, the biases are important. when we consider how to employ this. And we should be asking those questions. Okay, there's two companies that I want to highlight here. Gretel AI, they create synthetic data to improve models without compromising privacy. So that's that finance data, that's that healthcare data that you can take into a model and you can improve it before employing it into the real world. There's also, Synthesia or Reverie AI. They help with synthetic media, videos, images, right? If you are on Instagram or TikTok or YouTube Shorts, I know you've seen an AI generated video. It's actually becoming kind of overly prevalent and intrusive, but there's also some incredible ways that you can use that technology for good in terms of video games or modeling a real world. But I just see it and I'm like, this is it's hollow still. But these companies are exploring how to do this synthetic data generation that is living within our world right now.
This is going to be quite the time to see how this is utilized. I am really happy to hear how you described it, Nate. And if I could, my personal takeaway is in the short term, synthetic data's got a lot of value in the world of physical AI. And in terms of generalizing cases where you have a wide, I'll say population, not just a human medical aspect, but you have a large group or a large population where you can have a set of generalized cases, then synthetic data is a good start point to quickly build through that learning curve so that your models can more accurately and more quickly go after the unique cases or the generalized solutions.
Yeah, I think that's right. And, where do we see this going in the next 1 to 2 and 2 to 5 years, right? I think we're going to see a growing use of synthetic data in the finance and healthcare world as they deploy models in an environment to get them to a place where they can be employed on real data, which I think is a good use of this synthetic data. We're also going to see it and have seen it in AI-generated videos, deepfakes, right? They're becoming very advanced and very hard to tell the difference between what is real and what is fake. There was actually a 6-hour auction in China on a social media with 2 AI-generated individuals based on real individuals, but they sold $7.5 million in merchandise over these 6 hours. And that was entirely AI generated. As the product came up, the AI agent started realizing what it was and talking about it. And these 2 individuals, just like you and me, are playing off each other and having a conversation. They had a conversation about a product in an auction that was live in China, and they sold $7.5 million of the product, right? And I don't know that anyone could have known the difference. They might not have cared, but I think that shows the incredible power of what's happening right now and where this is going. And in the next, 2 to 5, 2 to 7 years, right? I think synthetic data is going to become the standard in privacy in terms of healthcare and finance, for sure, in terms of model development. But we need to understand how to ask better questions of what is real. And it's going to make that line very hard to tell. And I think that's concerning.
That's a really great point, Nate. And I think back to the discussion we had with Matt Daly a few weeks ago and the discovery that if you know you're dealing with AI, you're more receptive to the fact. So right up front, I'm an AI algorithm. I'm talking to you about a topic versus if you don't know up front it's an AI algorithm and you proceed in a conversation and then subsequently discover that's an AI algorithm, you're less likely to trust the organization that AI agent is representing. That was 2 weeks ago.
Yeah.
And here we are 2 weeks later, and we may be at the point where our human's going to lose that ability to determine that it's not a real person that they're dealing with through this interaction, whatever it may be.
And that's a great transition towards what we're going to talk about next week, which is that synthetic knowledge and what these AI tools are doing to our minds and how we think, right? But I think, to cap kind of what we just talked about is synthetic everything, right? It's happening. Biology, it's happening in data. It's blurring boundaries in terms of what's real and what's not, but it's also going to be incredibly useful in what it provides us the ability to do. But I think, like you said, it's not the distant future. It's happening right now, and it's demanding our attention, and we need to make sure that we're navigating this responsibly.
Yeah, whether it's a tooth that's grown in a pig, a tooth that's grown in a lab, it's a steak. Where is it a steak from a cow or a steak from a lab? Which is better? What constitutes real and what constitutes the human experience going forward? Because it's possible we may be able to synthesize what would be perceived as a more real human experience than the pitfalls and shortfalls I mean, imagine a steak from a lab that tastes like a ribeye, but has zero fat, none of the downside.
Yeah, but the fat's what makes it good. I'm saying the fat's what makes it taste good.
Because if a real ribeye has the marbling, which is part of the flavor, which is part of the experience. But somebody somewhere is going to look at this and say, hey, we can synthesize a ribeye equivalent with zero fat, 100% protein, none of the downside. And is that in fact going to be real, or will that be the experience we simply accept because somebody somewhere has deemed it a more optimal element of the human experience than what is the base element of the human experience?
So, Jay, on that note, right, going back to your quote that started us off in The Matrix, right? In that movie, the character Mouse asks, how do the machines know that this is what the food they're eating tastes like? What if everything tastes like chicken? To which the response is, well, it's just a basic enzyme and protein structure, and that's the taste it has. And so you can synthesize it, and I think that's going to be phenomenal to see how this goes. And the synthetic everything has some awesome implications.
And this is only part one. So next week, we're going to come back at you with part two of synthetic everything.
Yeah, and we're going to ask a question, right? If AI can think for us, what happens to our own brains? What happens to our thinking? And this is a big topic we're going to unpack, and I can't wait to have this conversation with you, Jay.
I'm looking forward to it, Nate. And thanks so much for your time today. As always, another great discussion, and hope you have a great rest of the weekend.
Yeah, cheers.
Cheers.